All right, for this section, we're going to cover questions 3 through 6. Number 3, write each equation in the system. 2x minus y equals 6, and x equals 6 minus y in slope-intercept form. All right, I'm going to do this off to the side. 2x minus y equals 6. So I'm going to get y all by itself, so we subtract our 2x. We've got negative y equals negative 2x plus 6. Now we're going to divide by negative 1. So I got y equals 2x minus 6. So the first equation is y equals 2x minus 6. Let's take a look at the second one. The second one says x equals 6 minus y. All right, we're going to add y to both sides. That gives me y plus x equals 6. Now we subtract x from both sides. This gives me y equals negative x plus 6. So y equals negative x plus 6. Number 4, without graphing or solving, describe the solution of the system in item 3 and justify your response. So do you think I'm looking at parallel lines, one line, or intersecting lines? I think we're going to be looking at intersecting lines. Because the slope is not the same. Okay, so we've got intersecting lines, slope not the same, which would give us one solution. Verify your answer to item 4 by solving the system using any method. Revise your answer to item 4 if necessary. Okay, well, we've got them set equal to each other, right? We've got them both set equal to y, so we can set them equal to each other. So let's do that. 2x minus 6 equals negative x plus 6. So let's add 6 to both sides. That's going to give me 2x equals negative x plus 12. Now we're going to add x. That's going to give me 3x equals 12. We divide by 3. X equals 4. Well, that's only part of my answer. I also need my y value because remember, if they intersect, they're going to intersect at an ordered pair. Remember this said plug it back into one of our equations, right? So I'm going to do y equals 2 times 4 minus 6. Y equals 8 minus 6. So y equals 2. Now I'm going to plug this into my calculator just to verify that it is intersecting. I'm going to go back to my original 2 equations. So that was 2x minus y equals 6. And the second one is x equals 6 minus y. Well, they are intersecting. As you can see, the two lines go towards each other. If I click on this dot right here, it will tell me that ordered pair at which they cross And that ordered pair is 4, 2, which I had also guessed. All right, let's take a look at this next part. Question 6 says, intro to question 6 says, systems of linear equations are classified by relationships of their lines. Systems that produce two distinct lines when graphed are independent. Systems that produce coincident lines are dependent. So if I get 2 lines, it's independent. If I get 1 line, it's dependent. Systems that have no solution are inconsistent. Systems that have at least one solution are consistent. So we need to classify the systems in items 1, 2, and 3. So 1, let's go back to 1. 1, I had parallel lines, no solutions. So parallel lines means I had 2 separate lines, so that's independent. I had no solutions though, so that makes it inconsistent. Let's take a look at number 2. Number 2 was, at the bottom of the top page, no. 2 coincident lines, so 1 line, but infinitely many solutions. So that means, since it was coincident lines, those are dependent. And it has infinitely many solutions, so that would make it consistent because it has at least one solution. Okay, let's take a look at 3. 3, did I have 2 lines or 1? We had 2. So that makes it dependent lines. Did I have no solution or at least 1? I had 1, right? So that makes it consistent. On to the next section.